Hi, everyone. I'm Dr. Sam Leuthold. I'm a research scientist at Colorado State, where most of my work is soil biogeochemistry related. Within AI Leaf, I do a lot of machine learning and soil spectroscopy work. Can you describe your current research and how it connects with AI Leaf? My current research really focuses on using mid-infrared spectroscopy and machine learning to predict both the quantity of carbon in the soils as well as the form that it's stored in. Specifically, what we've been interested in is how it's divided between particulate and mineral-associated organic matter fractions. These fractions tell us a lot about soil organic matter formation and stability and functionality, and also how management decisions might influence it over time. During my PhD, I worked pretty extensively on the wet lab methods we use to isolate these fractions, which can be pretty expensive to scale and really quite arduous and potentially error prone. So using this mid-infrared spectroscopy allows us to dramatically scale up those measurements at a fraction of the cost and effort. Within kind of the auspices of AI Leaf, I'm trying to leverage these large heterogeneous data sets to make these predictions more accurate and maybe more transferable across different regions and different soil types. A lot of this work has been implemented through this open source R package we've been developing called Horizons, which is standardized kind of the data processing steps as well as these model pipelines to make things a little bit more reproducible and user-friendly. Broad strokes, ultimately what we're trying to do is bridge this major gap, moving from this really expensive and time-consuming lab analysis to a rapid field scale assessment of soil health and carbon storage potential. And I think as we think about AI Leaf's general goals, it really is getting at, how do we improve carbon accounting in croplands? How do we bolster these carbon markets and make them as effective and accurate as possible? And then, how do we put the best possible information into farmers' hands and spur kind of sustainable decision making? What are some of the most promising use cases of AI in sustainable agriculture? Yeah, it's a good question. I think there's a few different use cases that stand out. First, I've been able to work a little bit with this knowledge-guided machine learning across a few different projects now, and I'm pretty excited about the implications of that. One thing I've been thinking about a lot recently is the application of those tools to some of this mid-infrared data, and with the hope that we can scale these kind of fast, cost-effective measurements with process-based models like MEMS or DayCent, and then use these for more accurate or robust MMRV within the carbon markets. The idea is that it's both scalable and then kind of biophysically grounded by these KGML guardrails. MIR gives us this really nice high sample density and a low cost proxy for carbon, and this host of other soil physical chemical properties like texture and pH, all of our model inputs. And the process-based models keep that honest. And so that's an exciting direction in my mind. Something I've been hoping to find the time and the data to explore a little bit. Secondarily, I think AI and some of these different machine learning tools offer a really powerful means of doing multimodal fusion, where we integrate a lot of disparate signals into one output. One thing we've been working on recently is combining this mid-infrared measurements with remote sensing. So taking the satellite measurements and trying to pair them with measurements on the ground, and trying to get at if we can predict land degradation status. And that's all work led by Rupa Day in the Palikaras lab, and she has this really great conference paper coming out. So, I was really glad to be a part of that work. And I think it is a nice indication of what we can do with AI and machine learning and, this wealth of data that we have. Farm scale automation is something that I don't have a ton of experience with, but I've always thought is really going to be a game changer for sustainable and regenerative agriculture. I remember talking to my master's advisor however many years ago about robot ag. It's pretty exciting to think that between kind of advances in computer vision and more opportunities to understand the spatial heterogeneity of the farm kind of algorithmically, we're really getting to a place where we can fine-tune management and translate that insight into decisions and, hopefully deploy some of these kind of autonomous tools. And then, finally, kind of a nerdy one, but I'm really excited about how these growing data sets and the amount of compute that's available is letting us translate kind of micro scale mechanisms like microbial processes or mineral associations or aggregate dynamics into ecosystem scale predictions using emulation tools and new types of ML approaches. I think there's still so much to learn at the soil pore scale. And well, maybe that's stalled a little bit. I think AI could be a really powerful bridge for connecting those really micro scale dynamics up to kind of landscape scale outcomes.
What excites you about your research or work with AI Leaf?
I think the thing that excites me most about working with AI Leaf over the last year and a half is how it's kind of expanded the way that I think and work. You know, I came in as a postdoc with a largely experimental background, both in the lab and in the field. I was a soil biogeochemist with not much exposure to machine learning or anything like that. But being a part of this community has really pushed me to explore that and kind of learn an entirely new set of tools that are pretty central to my workflow now. You know, I think that agriculture really feels like a perfect testing ground for this kind of data intensive science. We have these really rich, spatially distributed data sets that capture these complex climate, by soil, by management, by crop genetics interactions, and all these interlevered soil biogeochemical processes across time. You know, it's not a billion points, but I do think there's a lot of mechanistic signal in that that's ripe for more causal exploration right now as we get more and more data in. At the AI Leaf retreat for impacts a couple of weeks ago, Jim Loganbush mentioned this book, The Fourth Paradigm, which gets to this idea of data intensive scientific discovery. So I just ordered it on a whim from this Goodwill in Colorado. It's been really interesting to page through because it does feel like we're experiencing that shift, even though this book was written in like 2007 or something. You know, we can use AI to deepen our mechanistic understanding and then use that mechanistic understanding to improve and refine the AI. And I think it turns into this really productive feedback loop that accelerates discovery in a non-trivial way. And then finally, I think it's deeply collaborative. You know, I've been fortunate to work closely with the Palcaras in their labs, with our process-based modeling team as they think about the integration of KGML into those tools. And I'm learning from a lot of expertises that are pretty far outside my own. And that spirit of collaboration, I guess, and the question it allows us to ask together is really exciting. And I think opens up a lot of doors for the future. Thank you so much for having me. I'm glad I got a chance to talk about this. So thank you.